Welcome to Unit 6, Exponents. We're going to do lessons 4 and 5 today, exponential graph with transformations. So basically what we're going to do is we're going to see this graph here, and we are going to graph using the transformations as we saw in Unit 3 and 5, A, B, H, and K. You're going to see that these transformations do the same thing. We're going to see what they affect in the exponential function, and then finally we're going to graph. So let's start. Here we go. Recall the basic function looking like this. N to the exponent x, we have the following properties. The y-intercept is always 0, 1. The domain xer, it's a joke. The range is y is greater than or equal to 0, and the asymptote is y equals 0. So transformations. The first transformation we'll look at is the a value, so that is the coefficient in front of the power. What does it do? So we're going to look at from Desmos, here is Desmos, and we're going to play with that a value. So here we go. If I'm going to shift the a value, pay close attention to what it affects. So here we go. Just like we saw in the other functions, we see it vertically stretches if it's bigger than 1. And then if we go back between 0 and 1, we see it's vertically compressed. And then if a is negative, here we can see that it is reflected through the x-axis. Also notice here that the y-intercept will change. So the y-intercept changes, we can see with the movement of a. And in fact, if I set a to be 3, I see my y-intercept will be 3. All right. So if you want to check that out, you can go to your phones and type in that web link, and you can actually do the same thing. All right, continuing on. What does A affect? Does it affect the y-intercept? Absolutely. It affects the y-intercept. Does it affect the domain? No. Domain is always the same. XCR. Does it affect the range? It actually does if A is negative. So it affects the range if A is negative. Does it affect the asymptote? No. The asymptote remains as is, and there we go. All right, so A, that's what it affects. All right, continuing on. In general, the y-intercept is 0a if there is no h value. If there is, then it becomes a little more complicated, but if there isn't, there we go. A is greater than 0. We say it's vertically stretched by a factor of a. If a is between 0 and 1, then we say it's vertically compressed by a factor of a. And if a is negative, we see it's reflected through the x-axis. Again, this is just a repeat of Unit 3. And even grade 10 academic math as well when we talked about quadratics. Continuing on. Transformations of the k value. So here we go. We're going to go back to our Desmos, and we're going to set a back to 1, and we're going to see what k affects. So here we go. Here is k. We can see we shift it up, and we shift it down again. It does that vertical transformation. And you can also see here it is affecting the asymptote. So there, if I set k equals to 4, we can see there's an asymptote here at y equals 4, and the function does not touch it. All right, so what does it change? It changes the y-intercept, absolutely. Here's my y-intercept right there. If I shift it up and down, I can see my y-intercept will change with that value. So it does affect the y-intercept. Domain, never Mr. Wills, come on. The range, absolutely it does, because it affects the asymptote. So it affects these three things. And by the way, the asymptote will always be y is equal to the k value. That's really important. All right. So y-intercept, y equals 0. The range will always be if a is positive, so then we have greater than or equal to k. If a is negative, then we will have less than or equal to k. So again, the k value is always in our range, and the equation of asymptote is always y equals k. So this is new. So k is actually quite powerful. It affects the range and the equation of asymptote. Also affects the y-intercept. Sorry, this is not quite right. So it should be a plus k. All right, again, this is if there is no h value. When there is an h value, we'll get into that later on. All right, k is greater than 0, we say it's vertically shifted up k units. If k is less than 0, we say vertically shifted down k units. All right, nothing new there. Let's continue. Transformation of the h value. So again, I'm going to go back to here. I'm going to set my k back to 0. Let's go k back to 0. And now I'm going to see what my h value affects. So here we go. H value, I'm going to shift it to I'm going to change this to, so it's plus. So then we can see that when h is positive, we can see that it's actually being shifted to the left. When h is negative, we can see it's being shifted to the right. What does it affect? Does it affect our range? No. It's still y is greater than or equal to 0. Does it affect our domain? Come on, Mr. Wills, that's a joke. Does it affect our y-intercept? Absolutely. You can see that gray dot there as I move it back and forth is changing as I change the h value, so it does affect the y-intercept. And does it affect the asymptote? No. So let's go here. Does it affect the y-intercept? Absolutely. Does it affect the domain? Never. Range? Nope. Asymptote? No. So really the only thing it affects here of those four major properties is simply the y-intercept. All right. When h is greater than 0, we say it is shifted h units to the left. When a is negative, we say it's shifted h units to the right. All right, final thing we want to look at is the b value. So here we go, I'm going to go back to b. Let's shift a back to h back to 0. Where are you? 0. There we go. All right, so b value. So pay attention. When b is bigger than 1, we can say it is horizontally compressed. It gets thinner. When b is between 0 and 1, we can see that it's horizontally stretched. And when b is negative, boom, we say it's reflected through the y-axis. And also between -1 and 0, we can see it's still compressed. And then less than -1, we can see it is, this is stretched between 0 and -1, and then less than -1, we can see it's compressed. So stretched anywhere between -1 and 1. All right. So what's changed? Well, is the y-intercept changed? Nope. Y-intercept will always still be 1, so the y-intercept does not change. Domain, that's a joke, never changed. Range, nope, that's not changed either, and the asymptote is also not changed. So it doesn't change any of these four. However, it definitely affects whether it is increasing, decreasing. Again, if we go here, right, my n value, my base value is 2. I can, by changing the b value, right now it's decreasing when it's negative, but then it's increasing when it's positive. So you can see I can change the increasing, decreasing property of the function. All right, when b is bigger than 1, we say it is horizontally compressed by a factor of 1 over b. And again, here we ignore the sign. So basically, this is really the absolute value of b. So if b is negative, we ignore it and just say it's bigger than 1. Again, b is between 0 and 1, and there we are going to take the absolute value of it. So there we say it's horizontally stretched by a factor of 1 over b. And if b is negative, we say it's reflected through the y-axis. All right. We've gone through the four transformations, what they look like on Desmos. Thank you, Desmos. And now what we're going to do is we're going to graph. So how do we graph this? Here we go. So we're always going to start with our n value, our base. If n is bigger than 1, we're going to use its positive table of values. Why would we do that? Well, if I go over here, I'm going to get rid of this, get rid of all of these, and I'm going to say f of x is equal to n to the exponent x. I can use a slider for n. You can see that when n is positive, all the big values are on the right side. So that's why we're going to use 0, 1, and 2. When n is between 0 and 1, we can see all the big values on the left. So that's why we're going to use -2, -1, and 0. And that's what this says. If n is greater than 1, we're going to use positive table values. If n is between 0 and 1, we're going to use the negative table values. All right. Once we do that, we are going to fill out the y values given the n values. So what does that mean? Let's say I had the function f of x equals a, whatever a is, and let's say I've got 2, and then b x minus h plus k. So here I can see that my n value is greater than 1. So I'm going to go over here. So here I'm going to use y is equal to 2 to the exponent x. So the first one would be 2 to the exponent 0, which is 1, 2 to the exponent 1, which is 2, and then 2 to the exponent 2, which is 4. So that's my base table values. What if I had this? What if I had f of x equals a 1 over 3 b x minus h plus k? Well, in this fact here, my n value is between 0 and 1, so I'm going to use a negative set of values. So here I'm going to do, this is going to be equal to 1 over 3 to the exponent x. So here I'd have 1 over 3 to the exponent negative 2. If I did that, I get 9. 1 over 3 to the exponent negative 1, that gives me 3. And then anything to the exponent 0 is 1. So again, depending on the base, if it's bigger than 1, we're going to use positive, 0, 1, 2. If it's between 0 and 1, we're going to use negative, negative 2, negative 1, 0, again, because it's that increasing, decreasing. So then we find the y values, which is what I did. Then we're going to multiply the y values by a and the x values by 1 over b. And then we're going to add the y values by k and the x values by h. I'm going to combine these two steps again. And you notice that these are both the same on either side. And then finally, we're going to create the scale and graph the asymptote. That's just our k value. And the one point I don't have down here is that we are going to plot the points and then draw a smooth curve. So here we're going to do 2 examples, and that'll be the lesson. So here's my first one. My first equation looks like this. Y equals negative 2, 3 to the exponent 2, x minus 3 plus 8. The first thing we're going to do is we're going to determine the asymptote. I'm not going to graph it yet. I'm going to graph it after I get my y values here because I want to know my scale. You'll notice when I give you the graph, you'll notice I never give you y values because I want to see you create them, because sometimes you can have really big numbers like 100, and of course then you wouldn't want to go by ones. So here's my asymptote. My asymptote will be y equals 8. Where does that come from? It comes from that value there. All right, pretty straightforward. Then I look at my base. So here's my base. My base is 3. That is greater than 1. So I'm going to use a positive set of values for x. I'm going to use 0, 1, and 2. And then here my y is equal to 3 to the exponent x. Just the base to the exponent x. Let's get rid of that so we can see what I have here. All right, there we go. So here this is going to be 3 to the exponent 0. That's 1. 3 to the exponent 1, that's 3. And 3 to the exponent 2, that is 9. So that is my base table values. All right, now to my x's, I'm going to look here. I've got a 2 for my b value, so you can multiply 1/2 or divide by 2. I'm going to divide by 2, just like we did with the sinusoidal function. So divide by 2, again, that's my b value. And then I'm going to add my h, so I'm going to add 3, and that's my h value. So I'm going to have here 0 divided by 2 plus 3. So I'm going to graph 3. There's my x value. Here I'm going to do 1, so 1 divided by 2, that's 0.5 plus 3. So this is going to give me 3.5. Then finally I'm going to have this 2 divided by 2 plus 3. That's 1 plus 3, that's 4. So these guys here, I'll highlight them. These are my x values. All right, let's continue my y values. Here I'm going to multiply by negative 2. That's my a. And then I'm going to add 8. That's my k. All right, there we go. So I'm going to take my y values I've determined over here. So 1 times negative 2, that's negative 2 plus 8. And that is 6. Next one I'm going to do is 3. 3 times negative 2 plus 8. And that gives me 2. Then finally I'm going to have 9 times negative 2 plus 8. That is negative 10. Negative 18 plus 8, yeah, that's negative 10. And then I'm going to graph my y values here. All right, notice I haven't done my asymptote yet. My asymptote requires a scale, and it looks like my biggest y value is 6, my smallest y value is negative 10, and I believe I've got 11 here, so I can just go by 2's. So let's do this. All right, so this is going to be 2, 4, 6, 8, 10, negative 2, negative 4, -6, -8, -10. All right, there we go. I'm going to draw my asymptote. My asymptote going up here is y equals 8. So let's do that. Again, please use a ruler. This is pretty poor. Not bad, Mr. Wills, not bad. So there's my asymptote. Now I'm going to plot my points. My first point is 3, 6. So 3 and 6, there we go. My next point is 3.5, and notice here, each of these ticks is worth 0.5 because I've got 2 ticks to 1. So I'm going to have 3.5 and 2. I do that on purpose because whenever my b value is 2, then I know I was going to have 0.5s. So there is 3.5 and 2. And then finally, my last one will be 4 and -10, so way down here. All right, Mr. Wills, how do you do that? I've got 3 points, I've got an asymptote, so what I'm going to do is connect these. I can see my functions decreasing, so over here, I'm going to something close to my asymptote, and then I'm going to go down, and I'm going to have 2 arrows. And there we go. Now that arrow is not great. Let's see if I fix that. And I'm just going to put a little arrow here. There we go, not bad. You can probably do it better. Again, I'm graphing on my computer screen, so I'm not doing the best job, but there we go. All right, asymptote, y equals 8. Range, that's an 8, by the way. My range will be y such that y below my asymptote, so less than, my k value is 8, and y, e, r. Domain, that's a joke. X, such that x belongs to the reals, that never changes. Increasing or decreasing as I go from left to right, I can see the y values are getting smaller, so this is a decreasing function. Now, y-intercept, Mr. Wills, you left that one. Yes, I did, because this is going to be a bit tricky. My y-intercept, for any y-intercept, x is always equal to 0. So, what do I do here? I'm going to set x equal to 0 and solve, so I'm going to find f at 0. So here I'm going to have -2, 3 to the exponent of 2, 0 minus 3, plus 8. Plug that in my calculator. I will have, excuse me while I try this, so I'm going to have here -2 times 3 to the exponent. 2 times -3 is -6, and then plus 8, and so here I get 7.997. So my y-intercept will be 0 and 7, oops, 0 and 7.997. So that point would be right there. Pretty accurate. As good as it's going to get. Transformations. Here we go for transformations. So transformations, please excuse my terrible writing here. The first one, a is negative, so I can see it is reflected. I'm just going to type it, sorry. So my first one will be this. Reflected through, make that writing a lot smaller. Reflected through the x-axis, vertically stretched by a factor of 2. Those are both from A. From B, so again, that's from my A value. I'll just put it in brackets here. This is also from my A value. You don't need to do this, of course, but just showing where I get it from. Finally, or next I'm going to do a horizontally compressed by a factor of 1 over 2. This is for my B. My B value is 2, so it's always the reciprocal. It is also horizontally shifted 3 units to the right. That's again my B value, or it's my H value, sorry. And then finally, it is vertically shifted up 8 units. And there we go, and that's my K value. All right, there are my transformations. All right, let's do the next one, example 2. So we're going to graph this guy. Asymptote, well, pretty straightforward. y equals -2. Don't graph it yet, Mr. Wills. Wait to see the scale. All right, notice here, my h value has not been factored out. My b value, sorry, hasn't been factored out. So I really have f of x equals 2, 1 over 3, 0.5, x minus 2. Where's the 2 come from? I'll explain that in a second. But if you remember from other units, this is just going to be -1 divided by 0.5. I divided both these terms by 0.5. So there we go. I've got that. Base table of values. Here we go. So since my base, my n value, is between 0 and 1, I'm going to use the negative side. So -2, -1, and 0. Y here is going to be equal to 1 over 3 to the exponent x. So here I'm going to have 1 over 3 exponent of -2, that's 9. 1 over 3 to the -1, that's 3. And then anything exponent of 0 is 1. So there we go. I'm just going to fix that. So 3 and 1. All right. Now I'm going to apply my transformations. So to x, I am going to multiply by my b value here is 0.5. So I'm going to multiply by 2. That is my b. The reciprocal of a half is 2. And then I'm also going to add 2. That's my h value. So here I'm going to have -2 times 2 plus 2. So that's -4 plus 2. That's -2. Here I'm going to have -1 times 2 plus 2. That will be 0. And then finally I'm going to have 0 times 2 plus 2. That will give me 2. So these guys right here, these are my x values. And then here for my y, I am going to multiply by 2. That's my a value. And then I'm going to subtract by 2. That's my k. So here I'm going to have 9 times 2 minus 2. That is 16. Woohoo, my favorite number. And we're going to have 3 times 2 minus 2. That is 4. And then I'm going to have here 1 times 2 minus 2. That will give me 0. And these guys here, these are my y's. All right, now I can set my scale. My scale here, my biggest y value is 16, my smallest y value is 0. So it looks like I'm going to go by 2's. So here we go. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go. I'll just do 1 down here. My smallest y value is 0, so I'm pretty good to go. All right, I'm ready to graph my asymptote. Again, my asymptote is -2, I believe. My asymptote is -2. Let's be consistent here. I'll do it right. So here we go. I'm going to draw -2. Please enjoy those sound effects. They're free. There's the asymptote. Y equals -2. All right. Now I'm going to plot my points. My first point is -2 and 16, -2 and 16. So right about here. 0 and 4, which is right about here. And then finally 2 and 0, which is right here. And now I can see that my function is decreasing once again. And it's going to decrease right to that asymptote. So here we go. Let's see how smooth a curve I can draw on my computer screen. Terrible, Mr. Wills, terrible. Let's see if I can redo that. All right, let's try one more time. Oh, well, this is not bad. There should not be a hole right there, of course. It's not bad. I'd give myself a 7 out of 10. All right, so there it is. All right, range. So my range here will be y such that y, since it's above the asymptote, greater than -2 y e r. All right. Domain joke. Try this again. X such that x belongs to the reals. Increasing or decreasing, so I go from left to right, the y value is getting smaller, so it's decreasing. Y-intercept again, x is equal to 0, so I'm going to have f at 0. So it looks like I'm looking for something, well, actually, you can see it right there, it's 4. F at 0 is equal to 4. That was lucky. So that means my y-intercept is going to be 0, 4. No math really required. There is my y-intercept right there. All right. And so just finally, transformations. Here we go. Transformations. I'm going to type it out again. If I look at the function, my a value is 2, so it's going to be vertically stretched. Let's make this a lot smaller as well. Get this down to 18. Vertically stretched by a factor of 2. My b value is also 2, so it's horizontally not stretched but compressed by a factor of 1 over 2. Actually, that is not true, sorry. It's been horizontally stretched, sorry, because my b value is 1/2, so horizontally stretched by a factor of 1 over, or by 2. That's reciprocal of 1/2. Also, it has been horizontally shifted 2 units to the right, and then finally vertically shifted up, down 2 units. So again, this is A, this is my B value, this is my H value, and this is my K value. And that concludes lesson 4 and 5 of exponents, graphing with transformations.